Okay, now you may not have to worry with these larger systems, but at least you'll have this if you want to come back to it maybe when you get into college algebra. But let's say I wanted to solve this large system that's x plus 2y minus 2z equals negative 2, 5x plus 9y minus 4z equals negative 3, and 3x plus 4y minus 5z equals negative 3. Now this is a system that's a 3 by 3 system, so it's got 3 equations and 3 variables. So to solve this by the elimination method, I can actually use the first equation and second equation to eliminate x. So what I'm going to do here is I'm going to eliminate x from the first equation and the second equation, and in order to do that I'm going to multiply the first equation by negative 5. Now before I get into this, let me just tell you there's several different routes you can take in solving these equations. So maybe I start out and eliminate z's instead of x's, or maybe I use a different pair of equation to eliminate x's. But the idea is to first of all pick 2 equations and eliminate a variable, then pick 2 different equations and eliminate the same variable in the next step. And I'll show you that in a minute. So right now I'm choosing to eliminate x using the first and second equation. So I'm going to multiply the first equation by negative 5. And so when I do that, I have negative 5 times everything in the first equation. And then I just brought the second equation down just so you could see them together. Now when I multiply everything by negative 5 in the first equation, that's going to give me negative 5x minus 10y plus 10z equals 10, positive 10. And then when I add these two together, so I'm going to actually add these two equations together, notice that the negative 5x plus 5x cancels, and the negative 10y plus 9y gives me minus y, and 10z minus 4z gives me 6z, and 10 minus 3 gives me 7. So by eliminating that, I get the equation minus y plus 6z equals 11. So we're going to hang on to that and use it later. Now, since I eliminated x here, I also want to eliminate x again, but this time I'm going to use the first equation and the third equation. So to eliminate x from the third equation, I'm going to actually multiply the first equation by negative 3. And so you can see I wrote the third equation under it. So multiply the first equation by negative 3. That way I'll have a negative 3x, and when I add it to this third equation, it'll cancel the x's. So that would multiply everything by negative 3. I get negative 3x minus 6y plus 6z equals positive 6. And now I'm going to add that to the third equation, and notice that when I add, the x's cancel again, and now I get negative 6y plus 4y is negative 2y, and then 6z minus 5z is 1z, and 6 minus 3 is 3. So now I have a second equation that involves y and z. So I had a first equation involving y and z, and now I have a second equation involving y and z. So if I take these two equations and put them together, here's the first equation, and then here's the second equation. And so I want to now try to solve for y and z from this system. Now, you'll notice I'm going to go ahead and multiply the first equation by negative 2. The reason I'm doing that is because if I multiply negative y by negative 2, it'll give me positive 2y. That way when I add it to this equation, the y's will cancel. So if I multiply negative y by negative 2, I've got to multiply everything else by negative 2. So negative 2 times negative y is 2y, negative 2 times 6z is negative 12z, and negative 2 times 7 is negative 14. Now if I add these together, 2y plus negative 2y cancels. Negative 12z plus z is negative 11z, and then negative 14 plus 3 is negative 11. And now all I have to do now is divide both sides by negative 11, and I get z equals 1. Okay, so now I can start what's called the back substitution. I can actually go back to one of these equations, it doesn't matter which one, I can go back to either this equation or this equation and plug in my z value and then solve for my y value. So it looks like I'm going to plug it into this equation. So I'm going to use this equation, minus 2y plus z equals 3. I'm going to plug the z value equals 1 in for it right there, so I get minus 2y plus 1 equals 3. Then subtract 1 from both sides, I get minus 2y equals 2. Then divide both sides by negative 2, and I get y equals negative 1. So now I have the z value, I have the y value. Now I've got to go back to one of my original equations. So I'm going to go back way up here and get one of my original equations. So I'm just going to take the first equation here, this one, and that's going to be x plus 2y minus 2z equals 2. And then I can plug in the z value, which is 1 right there for z, and I can plug in the y value I got, which is negative 1 right there. And so that's going to be x minus 2 equals negative 2. Well, that's x minus 4 equals negative 2. And then if you add 4 to both sides, you get x equal 2. So now that I've got all three values, I can write the solution as an ordered triple, where x equals 2, y equals negative 1, and z equals positive 1. Okay? Now, let me show you one more. Here's another example. This one, since the third equation has no z, it actually makes more sense to eliminate the z from, if I can eliminate the z from these two equations, then that'll give me an equation that doesn't have a z, and I can match it with this equation that doesn't have a z, and that'll make things a little bit easier to solve. I mean, if you wanted to, you could eliminate the x's from two equations and eliminate the x's from two other equations. But trust me, in this example, since the third equation doesn't have a z, it's easier to just take the first two equations and eliminate z. So if I take this equation and this equation and I want to eliminate z, what I need is a 3 here so that when I add them, the z's will cancel. Well, the only way I can get a 3 there is to multiply everything in this equation by 3. And so you can see here, I'm going to show you that's what I'm going to do. I'm going to multiply everything in the first equation by 3, and I get 3x plus 3y plus 3z equals 9, and then just bring my second equation down here, and then I can add these two equations together, and 3x plus 2x is 5x, 3y plus negative 2y is y, and then the z's cancel. 3z minus 3z is 0, and 9 plus 5 is 14. So now I got 5x plus y equals 14, and I can actually pair that up with this equation here, 3x minus 2y equals 24, because this equation has no z in it, just x and y, and this equation has no z in it, just x and y. So when I put them together, when I put the 5x plus y equals 14 with the 3x minus 2y equals 24, I can look for a way to eliminate either the x or the y. Now it looks like here, if I multiplied the 5x plus y equals 14 by 2, then that would allow me to eliminate the y. Because when I multiply everything by 2, I'll get 10x plus 2y equals 28. And then when I add that to the 3x minus 2y equals 24, the 2y and the minus 2y will cancel. So add those together, the y's cancel, and I get 10x plus 10x plus 3x is 13x, and 28 plus 24 is 52. So I get 13x equals 52. And then if you divide both sides by 13, we get x equals 4. Well, now I can back substitute, so I'm going to actually back substitute into the equation 5x plus y equals 14. And so I'm going to plug the 4 in for x, and I get 5 times 4 plus y equals 14. Well, that's 20. 20 plus y equals 14. So if I subtract 20 from both sides, I get y equals 14 minus 20, which is negative 6. So that's the y value. And now I'll go back to one of the original equations. How about this first one, x plus y plus z equals 3, and substitute in my x and y value. So take x plus y plus z equals 3, substitute in for x, you get a 4. The y value, we got -6. So put in 4 minus 6 plus z equals 3. Well, 4 minus 6 is -2, so -2 plus z must equal 3. And now add 2 to both sides, and we get z equals 5. And so now we get the solution. X is 4, y is -6, and z equals 5. And that's how you solve larger systems. You'll probably do this a little bit in college algebra, but then you may go ahead and go to matrices. I know if you go to college algebra or finite math, you'll learn to solve these using matrices. Okay, I'm going to solve this first one. This is an application of 3 equations. This says the sum of 3 positive numbers is 19. Find the second number if the third is 3 times the first and the second is 1 more than twice the first. So I'll take that back. I'm actually not going to solve these. Yeah, I'm not going to solve these. I'm actually just going to set these up. So here we'll let x be the first number, y the second number, and z be the third number. So since we know their sum is 19, we can say x plus y plus z is 19. And we know the second number, let's see, find the second. The third number is 3 times the first. So the third number, which is z, is actually 3 times the first number, so it's 3x. And then the second number, which is y, is 1 more than twice the first. So y would equal 2x plus 1. Now, you can actually rewrite these and move all the variables to the left by writing the second equation as minus 3x plus z equals 0, and the third equation by minus 2x plus y equals 0. Because if you wanted to solve it, that's actually how you would write it, so you could solve the system. Now, go ahead and read the second one here. Pause the video and read the second one, and then start it back, and I'll show you how to set up the second problem. Okay, so to set up the second problem, you know you have to have 1,500 radios. And so since x, y, and z represent the number of hours each plant operates, you know you get 18 radios per hour for plant 1, and 9 radios per hour from plant 2, and 20 radios per hour from plant 3. So 18x plus 9y plus 20z has to equal the total number of radios, 1,500. And then stereos, you know you get 17 stereos from plant 1 per hour, 12 stereos from plant 2 per hour, and 6 stereos from plant 3 per hour. So 17x plus 12y plus 6z has to equal the 1,250 radios or stereos that you have to make. And then for TVs, you get 5 TVs from plant 1 per hour, 10 from plant 2 per hour, and 9 from plant 3 per hour. And since you have to have 1,900 TVs, then 5x plus 10y plus 9z must equal 1,900. Okay, on this last one, again, pause the video and then read the problem, and then when you're done, go ahead and play the solution. Okay, so on this one, I'm going to let x be the amount invested at 5%, y the amount invested at 7%, and z the amount invested at 9%. So the amount of interest earned would be 0.07x on the first fund. Actually, it's 0.05x on the first fund, my bad. 0.07x on the second fund, and 0.09, dang, I messed this up. So 0.07y for the second fund, and 0.09z for the third fund. Okay, so you know you need to have a total of 20,000, so add them up, they must be 20,000. Add the interest earned up, because it tells you must have a total interest of 3,020. And then you know that the sum of the first 2 funds must equal the same amount that you invested for the third fund. So that would mean that x plus y must equal z. Okay. So anyway, that's how you solve and set up systems of 3 variables and 3 unknowns. And that pretty much completes this chapter.